Hello friends, this video on Hello Alkanes and Hello Arenes part 35 is brought to you by examfear.com. No more fear from exam. Let's see this ethanol to propane nitrile. This is my ethanol with ethanol and this is my propane nitrile. That is with propane nitrile. This is my propane nitrile. So OH I have to replace with CN. But OH is not a good leaving group. So first I can do is I can make this to chlorine or iodine, a good leaving group, and then I can replace with CN. Correct. So I have OH, I have to make it to, let's suppose I, so I'll make it to CCI. Or what I can do is I can react this guy with bromine in presence of phosphorus. In that case you'll get Br. Now any of these things you add KCN, is a very strong nucleophile, it will replace iodine or bromine. Any of these it will form CN. Right. This is also SN2 reaction. This is also SN2 reaction, right? Or SN2 reaction only actually. So in this case, you will get propane nitride. Let's see aniline to chlorobenzene. So this is my aniline with a benzene with a NH2 group. I have to convert this into chlorobenzene, that is Cl. So NH2 I have to replace to Cl. But NH2 is a poor leaving group. What should we do here? So in that case, what I can do is I can react this guy with HCl in presence of NaNO2 at a high temperature of 275 Kelvin. So what will happen is, in this case, it will become N2Cl. Right? It's called benzene diazonium chloride. This is called diazodiegenation reaction. So what happens here is, if I have HCl and I have NaNO2, sorry, Na, let's draw the diagram, and this is how it is, right? This is how it is. So this NaCl reacts, it comes out, and then there is a H plus here, right? It attacks, so H plus O and H comes out. So what you get is N plus. That's what you get. This is N double O, double bond O plus. This is what you get. And now this reacts with NH2 to form N2Cl. And now what you can do is pretty simple. You can take CuCl2 and you can get chlorine here. And this reaction is called Sandmeyer reaction. Sandmeyer reaction. Right? This is my chlorobenzene. So you have something N2Cl. If you want to get Cl, if you want to get rid of N2, you can use this Sandmeyer reaction where you react with CuCl2 and HCl also. So this will help in removing nitrogen. 2-chlorobutane to 3,4-dimethylhexane. So let's see what it is. 2-chlorobutane. This is my butane. At 2 I have a chlorine. 2,3,4-dimethylhexane. So this is my hexane. At 3 and 4 I have dimethyl. And this is 2C group. Right? This is CH3 group actually. Both places. This is what I have to convert. So if you see, there are 4 carbon. Here we have 6 carbon. So what we can do here? But to hex. So it has 8 carbon actually, if you see, 8 carbon. And if you see clearly, if you break this into 2 parts here, these is nothing but 2-chlorobutane, right? So similarly we can use Woosh reaction here now. So let's add this guy, right, with sodium, and Woosh reaction we need ether. Correct? This is equilibrium reaction. We want to precipitate out NaCl. So what you get is this. Sorry, CH3, CH3, CMC, and 2 NaCl. You precipitate out more and more NaCl because NaCl is not dissolved in ether and the reaction moves in the forward direction. Right? This is 3,4-dimethylhexane. This is generally used for even number of alkanes preparation, Woosh reaction. The next is 2-methyl 1-propene 2. Let's see. It's 2-methyl-1-propene, meth-ith-propene. At 2 I have a methyl group. Let me add here, looks better. 2-methyl-propane. At 2 I have a methyl group, and 2 I have a chlorine group. So I have to add chlorine here and hydrogen here, right? But yeah, this is what I have to add, right? Chlorine here and hydrogen here. I can directly add because it is normal Markovnikov rule. So I can just add HCl and you will get this product. Correct? Pretty easy. So the double bond here. Just have to add a chlorine here, hydrogen here. I can just add HCl using Markovnikov rule. Ethyl chloride with eth chloride to propanoic acid. Propanoic acid. This is what I have to convert. I have 2 carbons here, I have 3 carbon here. So what we can do here is Cl, if I can make it Cn, and then I can do hydrolysis. So pretty simple. Cl I can make Cn very easily. I can have this KCN. It's a very strong nucleophile. It will attack SN2 reaction. It will become Cn. That is propane nitrile. And this I can do hydrolysis. And I'll get this kind of product. Correct? Propanoic acid. The next is but1 into N-butyl iodide. So I have but1 into N-butyl iodide. So here I have to see iodide, sorry, iodine. So here I have to add iodine at this position. If I just add Hi, iodine will be added here because of Markovnikov rule. But we have to add anti-Markovnikov addition. So first we have to add HBr in the presence of peroxide. Right? So what you get is this compound. Correct? And this I can replace bromine with iodine by NaI and ether. So with this, bromine will be replaced with I. Winckelstein reaction. That's what you will get. Pretty easy. The next is chloropropane, 2-chloropropane to propanol. So I have 2-chloropropane, this guy, to propanol. Meth-ith-propanol. So see, the number of carbon is same, but chlorine has to be replaced with OH. But if you see, chlorine was here in the second carbon, here OH in the second carbon, third carbon. So what we have to do is first we have to make double bond, remove chlorine, and then we can add water. Correct? So let's do that. So I have this compound, remove chlorine, I have to use alcoholic KOH, right? Alcoholic KOH. And some heat, dehydrohalogenation. I'll get something like this. Now on this, if I add water directly, it will be added here. Correct? Because of my Markovnikov rule. But I want to add here. So I have to again go for HBr using peroxide. So it will be a free radical reaction. So it will form, give me this compound, 1-bromopropane. On this, now I will use aqueous KOH. Please note, here I have used alkaline KOH for dehydrohalogenation and aqueous KOH for nucleophilic substitution. KOH minus is a nucleophile, right? So this will give me this compound. So please note, alcoholic KOH is used for dehydrohalogenation. Why I explained one, where you see if you use for example C2H5OH and alcohol, so this reacts and it forms C2H5O minus, and it's a very strong base. Since it's a very strong base, you have elimination reaction here. You have to convert chlorobenzene to para-nitrophenol. So a chlorobenzene, it's a para-nitrogen group. So first I can convert into nitro, right? So what we can do is I can just add HNO3 in presence of sulfuric acid, go for a nitration reaction, I'll get something like this. This is a major product actually. And the only thing I have left is I have to replace this chlorine with OH. I can do that. I can use my aqueous KOH or NaOH with some dilute HCl. Any of these I can use. So with this, Cl will be replaced with OH. So this will be my substitution reaction, and this will also be a substitution reaction. This will be my electrophilic substitution reaction, and this will be nucleophilic substitution reaction. 2 bromopropane to 1 bromopropane. I think we have seen this example a couple of times. I have a propane here. I have to convert, put this bromine here, right? Pretty easy actually. What generally we do is we make it a double bond by removing HBr, and then we can go for an anti-Markovnikov rule addition. So let's do this. For removing HBr, we use alcoholic KOH, right? Dehydrohalogenation. So what you get is, see this guy, and now on this we'll add HBr. But since we want Br in the end, so we'll go for anti-Markovnikov addition and we'll use peroxide. And what you get is this guy, 1 bromopropane. Now it is chloroethane to butane. So I have meth-eth chloroethane, meth-eth chlorobute. So if you see, if you break this, you get butane, you get 2 ethanes actually. That means I can use Woods reaction pretty easily, right? I can just use Woods reaction. So I have this guy. I'll use 2 of these guys with sodium in dry ether. So I'll get butane plus 2 NaCl. The next is benzene to diphenyl. I think we have done this also. This was a benzene, and you want to make it to diphenyl. So what we told there was you convert this benzene to add some chlorine or something. So you get this chlorine, you add 2 of this in sodium, same Woods reaction, and you get something like this. Again, Woods reaction. We have discussed this free radical reaction, Woods reaction. The next is tertiary butyl bromide to isobutyl bromide. So I have a tertiary butyl bromide. I have to convert into isobutyl bromide. This is what I have to convert. That means I have to move bromine from here to here. Same thing we have done. We'll just remove HBr, right? And then we can add using anti-Markovnikov rule. Right, so let's see this. So we have seen this kind of reaction so many times. In use to remove HBr, we use alcoholic KOH, dehydrohalogenation. What you get is this guy, and on this we'll add HBr. So since you want to add Br here, we'll use anti-Markovnikov rule. So we'll use peroxide, and we'll get what we are looking for. Correct? Isobutyl bromide. The next is aniline to phenyl isocyanide. This is my aniline. I have to convert into phenyl isocyanide, that is this guy. So what I can do is I can just react this guy with CHCl3 and KOH. With this I get this product. Plus you'll also get 3 KCl and 3 water molecule. The treatment of alkyl chloride with aqueous KOH leads to formation of alcohol, but in the presence of alcoholic KOH, we get alkene. We have seen this actually. We have RCl. If you use aqueous KOH, we get ROH. But if you use alcoholic KOH, we get alkene. And that means we have dehydrohalogenation reaction, right? So this is my generally E2 reaction, and this is my SN2 reaction. The question is what is happening here. So if you talk about aqueous KOH, you have KOH, it breaks into K plus OH minus, right? So OH minus is a strong nucleophile. Since it is a strong nucleophile, it goes for SN2 reaction. Correct. So it replaces the chlorine here. For example, I have RCl, I have OH minus. Replace the chlorine to form ROH. This is for aqueous. If you talk about alcoholic, that means let's suppose I have methyl alcohol present here and I have KOH here. KOH will be nothing but K plus OH minus. OH minus will react with this H and will form C2H5O minus and H2O. Correct. This C2H5O minus is a very strong base. As I told, if you use a very strong base, you generally end up in having elimination reaction. If you use strong nucleophile, you get elimination reaction. Sorry, substitution reactions. Right? It's a very strong base. It's a very strong base, and thus what it does is I have, let's suppose, a compound here, CH3, CH2, CH2, and CO. This C2H5O minus will pull this hydrogen. This is a beta hydrogen, will pull this hydrogen and it will go for, it will take this hydrogen and then it will force this chlorine to kick out. And then you will get CH3, CH, double bond, CH2. That's what will happen because it's a very strong base. So it's a very strong base, it generally favors elimination reaction. It's a strong nucleophile, it favors substitution reaction. The question is what happens when N-butyl chloride is treated with alcoholic KOH. So I have N-butyl chloride plus alcoholic KOH. As I told, alcoholic KOH does dehydrohalogenation. Remove this chlorine and one hydrogen from here. So what you get is this compound, but1ene. Bromobenzene is treated with Mg in presence of dry ether. So I have a bromobenzene and I'm hitting with bromobenzene in the presence of magnesium in ether, dry ether. I get RMgX, that is Grignard reagent, that is this guy, and then MgBr. Phenyl magnesium bromide, very easy reaction. Chlorobenzene is subject to hydrolysis. This is my chlorobenzene. So chlorobenzene under normal condition, there will be no hydrolysis. It's pretty stable, right? But we heat this with NaOH at very high temperature, 623 Kelvin, 300 atm pressure, it will give phenol. Correct. So at normal condition, it won't be hydrolyzed chlorobenzene, but at the high temperature and pressure, it will be converted to phenol. Ethyl chloride is treated with aqueous KOH. As I told, aqueous KOH is nothing but a good nucleophile, right? So it will go for a substitution reaction. So OH minus will replace this chlorine. So what you get is ethanol plus KCl. The next is methyl bromide, that is CH3Br, treated with sodium in presence of dry ether. So again, this is my Woods reaction, so I'll add 2 here. So what you get is CH3, that is ethane you'll get, plus 2 NaBr. The next is methyl chloride is treated with KCN. So I have CH3Cl and I have a KCN. So KCN, Cn minus is a very strong nucleophile. It will replace this chlorine and you get CH3Cn and plus KCl. CH3Cl is nothing but methyl cyanide. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.